So you need to decide which of these does not belong and why. There are multiple answers for multiple different reasons. So think amongst yourselves, talk to each other. I'll give you a few minutes to look through these, talk about them, and then we'll come back and talk about them together. All right, what do we think? Which one does not belong and why?
I think all of them have their own unique aspects, but D especially has a y-intercept 2 instead of -1, like the rest of them. So you solve this. Equals -1. And this is the one that doesn't belong because it has a different y-intercept. All of the other ones have -1.
Okay, so D for the y-intercept. Anyone have a different answer or the same answer for a different reason?
Is that what you were gonna say?
Okay. There are other answers. If I said A didn't belong, why would A not belong? So I heard different things. What did you say? There is something specific about the slope. We'll come back to that. Okay, what did you say? Okay, so like it's written in slope intercept form. That could be a reason why it didn't. You don't have to write these down. I'm just writing. Any other reasons why A would not belong? So there are obvious reasons why each of these don't belong and non-obvious reasons that you may have had to solve or figure out. Why wouldn't B belong? What's an obvious reason that B wouldn't belong? The slope, the y-intercept. Either it's not related. It's going down. That's negative. We're going up and left.
It's the only one as a graphic.
The obvious reasons. The only graph. C would be an obvious reason. Table. Before we solve D, what would have been the obvious reason for D? Music is too loud. Standard form. It's the only one of the standard ones. Okay, and then if we figure these out more, what would the equation of this one be? Y equals -2x minus 1. This one, if you were looking for the slope, you could do it algebraically. You could have used decimals, put it into your calculator, either or to find your slope or discount. You're looking at your change in y over your change in x. Here we're going down 2, here we're going up 3, -2/x minus 1. So if we're comparing all of the equations, which one doesn't belong now? So we said D already because the y-intercept.
A because it doesn't have a 2 in
So A is the only one that doesn't have a 2 in the slope or in the equation at all. Okay. Any other reasons? That's a good majority of them. So there were obvious reasons, there were non-obvious reasons that we had to solve or figure out. So any of those could have been reasons why any of them did not belong. Okay, cool. So we are going to finish our graphing note. And that should put us around 1. And then we'll move on to make. Does anyone need another copy of the graphing note? Ada. No, Ada. Okay. So we are going to, just refresher. We talked about how to graph when it's in slope-intercept form, how to graph when it's in standard form, how to graph when we have horizontal and vertical lines. This is the last way to graph. By intercepts. This is similar to when we were solving intercepts and it looked in this format, in standard form. But we are not going to convert these. We're going to do exactly what we did for solving with missing some steps. So the steps here cover up the y term, solve for x. Cover up the x term, solve for y. Similar to what we did when we were solving intercepts, but the math part. I'm going to explain that here in a second. So the cover up the y term, that would be like me putting 0 in here, this becoming 0, and then me writing everything else to solve for it. For the cover up the x term, same thing, that would be similar to me putting 0 in for x, this becoming 0, that going away, and then we just writing the rest and solve it for that. Yes, but we're not going to put the zeros in. Oh. So similar, yes, but we're skipping steps. So for graphing by intercepts, you can skip these steps, but if you were solving the intercepts, you would have to show all the work. So for number 1, if we were solving for, it doesn't matter which one we do first, but let's say we're solving for the x-intercept, covering up the y term, I'm writing what's left. And I'm solving for x, dividing both sides by 3. And I'm plotting this point at -3. We do not need to write these as order pairs because we're not solving for intercepts. We're just graphing by intercepts. We will do the same thing for the y. Cover up the x term, put what's left. Solve both sides. This should be -2, not -3 for the x. But this one is negative. Positive. Wait, sorry. Right. When graphing by intercepts, you only need 2 points, your x and y intercept. That is all you should be plotting. After that, you can make a line. So if you want a ruler again, we'll grab that. But we are not graphing by slope here, so we should not have multiple points. We should only have 2. So if it does not specify how you need to graph it, you can either convert it back to slope-intercept form and graph it that way, or you can graph it by intercepts but only have 2 points. You should not be mixing and matching. Now, if it does specify graph by intercepts or graph by slope-intercept form, then you have to do it that way. Questions on that one? Let's do number 2. If we are solving for x, we cover up the y term, what's left? There is no work. Oh. So then if we're doing the y, covering up the x term, what's left? And then solve. Put a point between those 2 points. Look and see if there are any others 3 through, what number is this? 6 on this page or 7 through 10 on the other page. None of the 6. Both at 3. Okay, so as we kind of already figured out, number 3 would just be x equals 3 plotted at 3, and y equals 3 plotted at 3. So there's no work for that one. You would still have to write x equals 3, y equals 3, but then you would just follow 2 points. Okay. For number 4, we're solving for x with left. If we cover up the y term. Right, and then when we solve, x equals -5, so we will plot a point at -5. Do the same thing for y. If we cover up the x term was left, y equals 20, divide both sides by 5, so that y equals draw a line with those 2 points. Okay, number 5, if we're solving for x, get rid of the y term, what's left? Divide both sides by 4, so that x equals -1. And then if we cover up the x term, what's left? -y. Don't forget about that negative equals -4. So to get y by itself, by both sides by negative, not y, but the number that y equals 1. Yes. Your lines have to have arrows. They keep going on forever and ever in both directions, so they have to have arrows. Any other questions in 6 through 10? $43. 10:43. We're going to switch gears. Okay, we'll have time to like take down these notes. Prior to us taking down these notes, I wanted to mention this. So 1, if you haven't been working on your Delta math, there are a bunch due on Friday. Slope part 1, slope part 2, x and y intercepts, graphing linear equations. Then on what we're about to do, there's not a Delta math, but there's still a practice for it that will still go in as an informative grade. So on Canvas, if you go into the linear transformations assignment, I don't exactly remember what it's called. You have 2 options. You can either do the Desmos activity, or you can do the go formative activity. Does not matter which one, don't do both. But whichever one you choose, you have to email me so I can go in and grade it, get the grade for you to put that in. So that is also due on Friday. We have 5 things due on Friday. So if you haven't been working on those, make sure you do that. Make sure you do the practice for this one as well. Go through Canvas to find that. Questions on that? Okay. So the last lesson in this unit that we have to talk about is transformations, which is like a mixture of a bunch of the stuff that we've already talked about. Slope, y-intercepts, graphing. That's it. But in order to do the transformation stuff, you need some background information. I'm gonna have you write some stuff down. You need to do this at the top, right at the bottom, wherever you have space. So there are 3 transformations that you need to know. One of them is for slope, the other 2 are for, one of them is for y-intercept, the other 2 are for slope. So let's start with the y-intercept first. So for the y-intercept, the transformation word that applies to y-intercept is the word shifted. So the y-intercept can be shifted up or down. So when you talk about or see the word shifted, it's only applying to the y-intercept. It's only moving, basically, is what shifted means, up or down. And function-wise, you see it either being added or subtracted. So it's not going to make a whole lot of sense right now, but once we actually start to use it, it will make one. Right? Then slope, the 2 for slope, one of them is slope can be reflected. So we're gonna write this down here in a moment, but all of these transformations are comparing whatever it is currently to the original. We'll talk about the original here in a minute. But if it's reflected, it has a negative. The slope is negative. The reflected, it means that there is a negative. So that's one part. The other part is the actual numerical slope, whatever it is. That is the steepness of the slope. The steepness can be one of 2 things. It can either be steeper than the original or less steep. Not as steep. In order for the slope to be steeper, the slope has to be greater than 1. So we're going to put m greater than 1. So 2, 3, 4, 5, keep going. It would have to be some number bigger than 1. Or less steep is going to be a fraction or some number less than 1. I'm going to write 0 less than m less than 1. That just means it would be less than 1, but not dealing with the negatives. It can reflect and still be steeper. Those are 2 different things. The negative has nothing to do with the steepness. The number is the only thing that deals with the steepness. I'm going to write this last thing and then it'll be time for lunch. So I said that everything compares to the original. And that's your function f of x equals x or y equals x. Where, what would your slope be of this original? What's the number in front of x? 1. And what is your y-intercept? Blank. 0. So when we talk about all of these other ones, we're going to be comparing it to that. So when we get back, we'll talk more about that. Okay, let's focus. We're going to continue this. Okay. I can't remember if there was something else that I give you information on before we do this. Do we have questions about anything we've written so far? What do you see a Y value? Y is that here?
No.
No. So if you don't see one, it's here. Okay. So not only do we have to be able to describe transformations using these different words, we also have to graph them / describe them. I did forget to put one thing. While y-intercept is adding and subtracting, slope is multiplying and dividing. So for number 1 and number 2, we're going to describe what's happening based on the words that we just learned. So for number 1, we have to look at this and see what this would be doing based on our words. So we see it's adding, so that has to be something with the y-intercept. So it means the y-intercept was shifted. If it's adding, do we think it's shifted up or down? Up. So the y-intercept shifted up by 2. So you have to say which one you're talking about, the slope for the y-intercept. What did it do, depending on the transformation word, what direction, and by how much. Now, we have it adding, but then we're not multiplying or dividing. So that means nothing happened to the slope. So we can say the slope stays. Then in number 2, we are multiplying and dividing. So that would be something about the slope. There's going to be 2 separate things. You can write them as 2 separate things or one big thing and combine the sentence. The negative, there is a negative. So that means the slope was reflected. And then we have this 1/3. Would that be steeper or less steep? Less steep. It's a fraction. It's not bigger than 1. So that the slope is less steep, or I'll reword it here in a minute. Is less steep by 1/3. There are different ways to write that. You could say less steep by a factor of 1/3. It's 1/3 times as less steep, something like that. There are different ways to write it. Yes.
Why makes sense slope when we talk to?
Because of the negative. So anytime you see a negative, that deals with the reflection. But the reflected and the less steep have nothing to do with each other. That's why we have to put both things. Was there anything that happened to the y-intercept? There wasn't an added or subtracted something outside, so the y-intercept stayed the same. So you have to be able to recognize what's happening to what and how. Questions on either of those before we move on? Number 3 and 4, it does not say to describe, but we're going to do it anyway, just so we get good practice at describing. So here we have f of x minus 3. What is happening here? shifted down by. Y-intercept shifted down by 3. That was supposed to be. Correct. This one also asks us to plot 3 points. It does not say to plot 3 points to create the graph of the line, but we don't actually have to make the line. We just need to plot 3 points. So if the y-intercept originally, this is your original graph, was at 0, 0, and it's been shifted down 3. Where is it now? -3. So when it has you plot points, your y-intercept should always be one of them. And then if the slope stayed the same, you just need 2 other points that follow your slope pattern. Does not matter if you go to this way or to this way, or you want to do one on each, or you want to do skip a few and do 2 over here. It doesn't matter. You just need 2 more points. So I could do this one and this one, and that would work. Yours don't have to match mine. You just need 3 points. We are not going to connect these. We are not, going to make a line because that's not what it asks us to do. Questions on number 3? I mean, you can still sit up here. Okay, what is happening in number 4? Okay, the slope is increasing by 2. Okay, so instead of the word increasing, use our transformation words. It's steeper by 2, or you can say it's 2 times as steep, either or.
So we get taken off if we don't go like steeper, like increase.
Because we have to use the transformation words, yes. Have to use steeper or less steep, reflected, shifted.
We have to address all forms, or can we just like say the slope is now steeper? Do we have to say slope is steeper, y-intercept stay the same, if it's not reflected?
You have to say both. Something about the left at the end about the slope. So what happened to the y-intercept for this one? Nothing, it stayed the same. Now, if the slope stayed the same, you could say the steepness didn't change or stayed the same. That would be equivalent. For the y-intercept, you would just put it stays. The y-intercept stays. So if the y-intercept stayed the same, the point is going to be the same, starting at 0, 0. Excuse me. But now our slope is steeper by 2. So how would I draw 2 more points for that slope? Go up 2 to the right one. Need 1 more point. Doesn't matter if I keep going to the right or keep going to the left. Someone give me 1 more point. So if that's not what you did and you kept going up to right one, that's fine. You just need 3 points. Okay, questions on that one? Yes. Yes. Steeper and less steep when multiplied. Right, so now we're gonna go on to 5. And this is different because it's not a graph. We're not really describing, we are describing, but we have choices now. So we have our original, we have this new function, and we're comparing the 2. So in the 2 comparisons, we have to know what shifted is talking about. If shifted, if something is shifted, is that the y-intercept or the slope? The y-intercept. So we're comparing the original y-intercept to this new y-intercept. Did it shift up or down? Because it's positive. Right, and then the next one talks about the slope. So look at your original slope, compare it to the new slope. Would this be steeper or less steep? Less steep. Because it's a fraction. So if it's a fraction and the numerator is less than the denominator, it will be less steep. It could be a fraction where the opposite of what I just said is true, and it would be steeper. You could just pay attention to that. Fraction doesn't always mean less steep. Yes. So steeper would have to be some number greater than 1.
Less steeper is gonna be this.
Less steep will be some number between 0 and 1. So some fraction.
Okay.
Where the numerator is greater than the denominator. Go on to the next page. Now in these, we're doing the same thing, we're describing, but now we are also graphing. We have to graph it all the way through, not just a couple of points. So what happened in number 1? The negative and the 3 are two separate things. So I got steeper by 3. That happened. Got steeper. But what did the negative do? Reflected. So those are two separate things. The slope reflected and is steeper 3 times as steep. What about the y-intercept? It stayed the same. So now we have to graph it. If the y-intercept stayed the same, we're going to plot it at that same point. Okay. Now, if it's steeper by 3 and reflected, how would I draw this slope? Would go up and then right or left? Right. Left. So it has to go left because it's reflected, so it has that negative. So up 3 to the right 1 as many times as possible. And then left 1. And then down 3, right 1 as many times as possible. Connect all of those points.
So, why would the slope reflected? That's because it was.
So you can really see the steepness here from your slope. Think about steepness like if it were a cliff or a hill or something and you were sledding or skiing or skating or something down the hill, down these lines. Which one would you get down faster, the blue line or the red one? Blue. It's steeper.
How do you know this looking like?
Because it's negative. So then what happened in number 2? Y-intercept shifted up. So, and what happened to the slope? Stayed the same. Or the steepness stayed the same. So what would your new y-intercept be? Positive 2 on the y-axis. Your slope stayed the same, so the original slope was 1, up 1 to the right 1. So we're going to do that, up 1, right 1 as many times as possible. And down 1, left 1 as many times as possible. My line is a little crooked, but the steepness is the same. We would get down these lines at the same rate, at the same amount. For number 3, would this be shifted up or down? Down, how do we know that? The y-intercept is -4. Would this be steeper or less steep? How do we know that? Less steep because it's a fraction, and the fraction has a numerator less than the denominator. So just because it's a fraction doesn't automatically mean it's less steep. Because if I had 3/2, that's more than 1. Okay, questions so far? Number 4 is describing these in a different way. You have your f of x equals x. If you want to draw that, I'm going to. You don't have to, but if you would like to also draw that so you can compare the original to the new, you can do that.
I need to know that X is equals.
Say that last part. One more time.
How does that?
This is the same thing. So I know that the slope is 1 and the y-intercept is 0. Okay. This one specifies, this one is talking about the slope of g of x, the new function. Remember that slope you were multiplying or dividing. So compare the original to the new. Which of these apply? What is the slope of the new function? That's the original. This one's the new. Doesn't matter. D. What's the slope here? D. So slope can't be adding or subtracting, so it can't be zero. It would have to be D. Because that's the only one that compares this slope up to the right 3 2/3 times 1. So what about the y-intercept, comparing the original to the new one? And these should be 3, not 2. C, 3 less than. It couldn't be 2 times more or 1/2 because y-intercepts isn't multiplying or dividing, it's adding or subtracting. 3 less than would be subtracting. With a C. Do we have questions on either of those for number 4?
So where?
Number 5. This one is like a combination of all the different types that we talked about. We are just going to plot 2 points. The part that says a line will extend to 2 points, that's if this were an SOL question, you were doing it on the computer, you would plot the 2 points and the line would automatically appear, but we're not creating a line. So if our new function, which is the original, is shifted up 5 units, what is our new y-intercept? At 5 on the y-axis. And if it's 1/2 as steep, what would our slope be? 1, 2. So you can choose one direction, go up 1 to the right 2, down 1 to the left 2. Maybe you don't want it so close and you want to do it a couple times, but don't put a point in the middle. You just need 2 points. Questions on that?
Why don't
Because we only need to plot 2 points. So it's really important that you pay attention to the directions. Some of them say graph a line or make a line. Some of them say plot a specific number of points. Don't plot more than the number of points it says. Don't put a line if it doesn't ask for one. Okay. Going on to the next. So now we're going to practice graphing as well as describing. It doesn't matter if you describe first or graph first. I'm going to graph the original once. If you choose to graph the original for the rest of them, that's completely. Remember that the original is y equals x. So for this, I'm going to graph that. You can do this. You don't have to do this. I'm only doing this so we can compare it to the original. If I were graphing this one, I would start at -5. My slope is positive 6/1, so I can go up 6 to the right one. I think this one's. I'd be off the graph if I did it again, but. So if I'm comparing this lighter line to my original, what changed? What happened? The darker one is the original, yes. Okay, so steeper by how much? 6. Slope is steeper by 6. Kate?
And the y intersection is down by.
Correct. So really, if you wanted to practice this, you could go back to all of your graphing and do this. If I were to draw this one, which happens to be the original. Did anything change? So in this case, we would put the slope and the y-intercept both stays. Just gonna do a few more. But let's jump down to number 5. So now we have to solve this, get it back in slope intercept form. How would we do that? Subtract x, divide afterward. So divide everything by 2. So the new equation is let's do this backwards this time. We graph first and then describe. Let's see if we can describe based on just the equation. What changed? What about the x? The number of x. Yeah. Okay. So that would be what transformation? Those are 2 different things. Sorry.
Those ones reflected. And it was, let's see. The wires. All of what's in there.
So the slope was reflected and is less steep by 1 path. So both of those things. And the right intercept was shifted up by. So now we can still graph it, but I wanted you to get in the habit of trying to do it with or without the graph. We up for the y-intercept, up 1 to the left 2 as many times as possible, down 1 to the right 2 as many times as possible. That's why I don't draw the lines. Okay, let's do the next one. We were solving that one, we would do what? Back to the next couple sides. That y equals negative 7x plus 5. What changed? Y-intercept was shifted up by 5. What else? Slope is reflected. And it is stupid by 7. Seven times as steeper by 7. Same. So that graph will look something like this. So we'll start at positive 5. We would go down 7. And to the right. Unless you go off. I want you to look at 7 and 8. See if you have questions on either. I will say that be careful because the graphs are counting by 2s instead of 1s. Did we want to do either of those? So then for the remainder of class, I'm going to give you different options. You can either go back and do the problems we did not do in this, which is really just the 2 on the back and go here. Doing your transformations. You could go back to your graphing and try your transformations there. Keep working in your graphing, just doing the graphing piece, either or. Work on, excuse me, your delta math / the linear transformations practice. Or if you would like more graphing practice and didn't do this last time because I don't remember, you can grab the graphing activity graphing box. You can be working on one of those. Does not matter which one. You can work together, use your notes, use Desmos. Let me know if you have questions. Use this time wisely. You can move around.